This is problem 9.11, and our first step is how we're going to approach this problem. What do we know is the angular acceleration is constant, meaning that we can apply angular acceleration to kinematics or motion equations to find the time and displacements. For that, we're going to need these variables. This is time, this angular displacement, angular acceleration, which is constant, the angular velocity initial, and the angular velocity final. We're going to use these two equations. The angular velocity final equal angular velocity initial plus acceleration, angular acceleration times time. And for the second part, we're going to use angular displacement, which is equal to this. So part A says, how much time does it take to reach 36.7 radians per second? That means the final angular velocity reach is going to be 36.7. What else we know? We know constant acceleration is 1.47. We know that the started at rest, meaning that initial angular velocity is equal to 0. Our target is find time. Using this equation, we can solve for time. Time is going to be equal angular velocity final minus angular velocity initial over angular acceleration. And we have this is going to be equal to 36.7 minus 0 over 1.47, which is gives us the time equals to 24.97 seconds. And this is for the first time, for the first part. Thank you. For the part B of this problem, we're gonna find the angular displacement and revolutions. So for that, we're gonna use this second equation, which says angular displacement equals to hold this. We know the initial velocity is 0. That time we find it is 24.97 plus 1/2 the angular acceleration, which is a constant, and it is 1.47 times the time, which is 24.97 squared. So this is going to 0, which is give you the angular displacement equals to 1/2 times 1.47 times 24.97 squared, which will give you 458.12 radians. But we're not looking for radians, we're looking for revolutions. And we know this, that 458.12 radians have to convert to revolutions like that. We know that 1 revolution is equal to 2 pi radians, which is this, cancel out the radians, and it gives you just a revolution, which is equal to 72.91 revolutions. Thank you, that's all for this problem.